Hi again. We shall now see what is remainder theorem. So let us consider a function like this. It is 6x cubed minus x squared minus 18x, and that function is going to be divided by 2x minus 1. So this is the general way of how we divide it. You can have a look at here that how we divide, and in that case you can see the quotient is here. This is the area of quotient, so place of quotient. So this is 3x squared plus x minus 17 by 2. That is the quotient. In this case 2x minus 1 is the divisor, and minus 15 by 2. After the division we have got the remainder as minus 15 by 2, and this is the given function that is to be divided by 2x minus 1. So once you divide with 2x minus 1, the remainder is, there is some remainder like minus 15 by 2. That means we can say that 2x minus 1 is not the factor of the given polynomial. In order to be 2x minus 1 as factor of the polynomial, there must be remainder 0. But at this time, as we are talking about remainder theorem, then we shall look for some pattern that we can develop through this kind of division. So in order to let you understand that how division of the things can be expressed, I am taking here a simple example of dividing 9 by 2. So here you can see when 9 is divided by 2, this is the process, and after that this is 4 whole plus 1 by 2 we have got from this division. So 9 by 2 can be expressed in this way also, 4 plus half. After taking the LCM and simplifying this, it is 2 times of 4 plus 1. But at this time I am not multiplying 2 and 4 because I have to develop some pattern to give it to the remainder theorem. So in that case, now in this case you can see 2 and 2 cancel out. So 9 can be expressed in terms of 2 times 4 plus 1 when it is divided by 2. And the same sort of thing you can see in the algebraic form also here, like 3x cubed minus x squared minus 18x plus 1 is divided by 2x minus 1. And then if you have look at here, this is the whole number, whole thing, that is the position of quotient. So just like saying 4 whole 1 by 2, you can say this whole, this minus 15 by 2, and then divided by 2x minus 1. So from this step to this step, it has been expressed just like in here. Now I am taking the LCM. LCM if I take, then it will go to multiply over here, and then at this part we are left with negative 15 by 2. Now comparing both sides, these two terms have been cancelled now. So our fx 6x cubed minus x squared minus 18x plus 1 can now be expressed as this denominator. That is 2x minus 1, 3x squared plus x minus 17 by 2 and plus minus 15 by 2. Now let's see what are these. So here in the division area, this is the dividend, and this is the quotient. We express that as qx, and this is the divider. So you can generalize the function like this. 2, you can say this is value a, x is there, and minus 1 you can see value b in general. Why I am writing a and b? Because this can be, these constants can be anything like 2, 3, 4, 5, 9, 6, 11, whatever. So if you are using this sort of symbolization, and then the main function that is going to be divided, you can express that as fx. So how you can write it here now? Your 2x minus 1 is in general going to be ax plus b, and this sort of thing is going to be qx, and plus this is the remainder part, so we can write r, and here for this it is fx. Alright, so any division that we can express in the form is, so therefore we can write in general fx is equals to ax plus b times quotient plus r. So fx can be expressed in this form when it is going to be divided by ax plus b here. Now let's see here. If you put ax plus b equals to 0, that means x is going to be minus b by a. then what happens? In that case, you can put x equals to minus b by a, then it's going to be f minus b by a is equals to a times of minus b by a in place of x. And then we have plus b, then close the bracket, q, and then you can again write here minus b by a, close the bracket, and r. And after that, what it is going to be? A in the denominator and in the numerator will cancel each other, and this is negative b and positive b, that makes it 0, so it is 0 times q minus b by a plus r, and finally you are left with r only. So say for a while minus b by a equals to c. Then we can write r equals to f minus b by a, means we can write f c is any constant, and this is called remainder theorem, as we have got the remainder by putting value c in fx, and therefore this is called the remainder. Now let's deal with an example so that it will be clear that how we can find the value of remainder in an equation or in polynomial division. So I'm going to copy out one question. In that case, the question says that find, okay. Now you can see that how we find the remainder in this case. So this is the divisor and this is function fx. So this is in fact fx and this is divisor. When you divide, when we are going to divide by this, your remainder will give fc, where you can see from the question that as it is x minus 1, so your c value is going to be plus 1. What if that will be x plus 1? Your c value would be negative 1. So therefore you can proceed further, like you put in place of x1 and your fx is here, your fx is here, so that will become 6 times of 1 cube plus 3 times of 1 square minus 5 times of 1, and then lastly it is plus 2. Now calculate this. This is going to be 6 plus, because it is 1, so there is no risk of plus and minus. This is 6 plus 3 minus 5 plus 2. So it is now 3 plus 2, 5, and 5 got cancelled out, so our answer is 6. So in this way you can find the remainder by using this formula. Now I will discuss about another question. The question is fx equals to, and now here you have to find, we are also given that fx has, so let's read out the question first of all. So here in this case, your given polynomial is this, that is fx equal to x cube plus x square plus bx minus 5, and values of a and b are not open here, and that you have to find based on the given conditions. So it is given that fx has a factor x minus 1. So when you put x equal to 1, the whole thing is going to be 0, that you have learned in the factor theorem. And in another part of the question, it says that it leaves a remainder of minus 6 when divided by x plus 1. That means in the second part of the question, you are using the remainder theorem. In the first part of the question, you have to use the factor theorem, because when it is divided by x minus 1, that leaves no remainder here. But in second part, you are using the remainder theorem, because when you divide the given polynomial by x plus 1, it leaves the remainder of minus 6. So by these two conditions, you will have two simultaneous equations, and when you solve those two simultaneous equations, you will have the values of a and b. If you would like to read it out, you can read it properly, or you can pause your video and then you can have a look at the question first. Since x minus 1 is a factor of the polynomial fx, f1 is going to be 0. That means your fx was x cube plus x square, so x cube means here 1 cube plus a times of 1 square plus b times of 1 minus 5 is going to be 0. Now solve it a bit. So it is going to be a, and this is b, and this is 1 minus 5 is minus 4, and if you transpose that to the another side, it is going to be 4. So you can say this is equation 1. Now another condition is that when it is divided by x plus 1, then it leaves remainder of minus 5. So it is given that f minus 1 is equals to minus 6. Why? Because another factor is x plus, you are going to divide by x plus 1, and when you put it 0, it is going to be minus 1, and it leaves remainder minus 6 according to the question. Now instead of plus 1, we put minus 1 in the same function fx, so it is going to be minus 1 cube plus a times of minus 1 square plus b times of minus 1 minus 5 is equals to not 0 now. It's given that this is minus 6. Then see how it is minus and power is odd, so it will be still negative. Now it is the negative power, the negative one is a square, this is going to be positive, so it is a. Now negative times positive is b, and this is minus 5. If you take it to another side, it's going to be minus 1. You can see both sides, negative 1 and negative 1, they will get cancelled, and eventually you have a minus b equals to 0 as equation 2. Now this is the turn to solve these equations to get the value of a and b. So we shall solve these two equations, or by using calculator we can easily solve these two equations. So I'm going to write it again. So our equation 1 is a plus b is equals to 4, and a minus b is going to be equals to 0. So this is equation 1 and this is equation 2. And now I will clear some space from here, so it can be easily solved here, because a minus b equals to 0, you don't need to use calculator, and even if you use this directly, it's going to be very simple. Either you can write a equals to b, and in equation 1 you put in place of a you can put b, or in place of b you can put a, and then you get the value of 1 of a and b. But at this time I'm going to this way, so I'm just going to adding these two. So if I add these two are cancelled. It is 2a equals to 4, that gives you a equals to 4 by 2 equals to 2, and since a minus b equals to 0, it gives you a equals to b, that is b equals to a, and a value is, we have 2, so that is going to be, a is going to be equals to, b is going to be equals to 2, as we put a equals to 2. Therefore value of a is 2, and also the value of b is 2, and these are the answer. Okay, that is all for now.